Hi there guys, I'm Chris Bowden and welcome to the Geek Group. Today we're going to talk about relays. This is a standard generic ISO, basic ice cube relay. This is when you think of relays, this is usually the first thing that people think of, and they call them ice cube relays because, well, it looks kind of like an ice cube. It's a little clear plastic thing with pins on the bottom. Different types of relays have different numbers of pins, and they're arranged the same way the pins on a vacuum tube are. So, yeah. What a relay is, though, eludes a lot of people, and we wanted to take a minute and talk about that so that we could cover the basics. Now, this works exactly the same way as a relay, but these are actually called contactors, is what this big giant thing is. But it works pretty much the same way. Now, here's how a relay works. A relay is an electromechanical switch. It works on an electromagnet. And the way it works is pretty cool. Here's how it goes. You have a little an arm inside with a contact on the top and the bottom. And this connects off to a wire. And we'll put on the wire, we'll put a battery, and we'll put a little light. That's my light. And this is the box of our relay. Okay? There's my light. Now, on the other side of the relay is a contact here that comes out, and we'll do another one in black. We have the black contact down here. It comes out this side. So we have three electrical connections on the relay. We have the common, we have normally closed, and we have normally open. And I'm going to actually move that a little because in actuality there's a little air gap here. Now, inside there we have a coil. And the coil is set up on a form, which is usually just a pin. And it sits in a base plate. Okay? So there's your basic ice cube relay. Now the way this works is on the coil here, we need red, so many colors. If you put across these two wires, say 12 volts. Common things on relays are 12 volts, 24 volts, which is often AC, and 120 volts. Now, if there's no electricity going across this, and our wire is connected on the green terminal over here, now when there's no electricity, this wiper is up, and it touches this, so it's normally closed. So in this instance, the light would be on. We apply voltage on here, and the magnet pulls the wiper down, so it changes from being connected here to being connected down here. So it goes from the normally closed to the normally open, at which point our light would turn off. That also works the other way. If you connect the wire down here to normally open, it works just like any other normally open switch. Without any power applied, connected from the normally open through our little battery light circuit to common, with no power applied, the light is off. When you apply power here, the light turns on. Now, this may be kind of dumb. You're like, well, why not just apply power to the light? This is used for things where the power you're applying here might be a 12-volt control circuit, and your light might be a big light. You can use a small voltage to control a very large voltage, or the other way around. You can use 12 volts to switch 5 volts or things like that. So this relay here is rated for up to 250 volts AC at 10 amps on the contactors, and I don't know if you can zoom in tight enough to see the little contactors on there. Take a look. You can see there's little contactors inside. Actually, I think I could open this right up, and you can take a look in. We can break a relay. Let's just pop it right open and share it with the world. Okay. Now if you take a look, here's the coil I was talking about. You can see that. the big round thing is the coil. And then here's the contactors on top, and they move. And you can even see it move there. So that's off, and that's on. And there's 2 wires that come out of the coil, and they actually go through a little neon light on this one, so you can tell when power is applied and whatnot. And yeah, that's the basics of it. You use a control voltage to handle a controlled voltage, and yeah, that's how it works. Now this works on a bigger scale. Here you have a thing with a 120 volt coil where you apply power in on these 2. And when that coil moves, it moves a big set of contacts which switch these 3 wires here. This is 3 poles down to the 3 down here. So you apply 120 volts here, and this is connected or disconnected. And it's got a thermal circuit breaker built into it as well. And here's another one. This is another big contactor. And you can, it's a 3-phase. It's rated for up to 575 volts. It's well, up to 600 volts, up to 90 amps, so it's pretty massive. And the controls on this are only 120 volts. And the way it works is when you apply power on the controls, it goes, and it makes that big chunk noise. And if you've ever seen any of the videos on like Gemini or Arcturus, right when it's starting to fire, you'll hear the control circuitry come on and you'll hear chunk, and that's the big main power contactors coming into play. So yeah, that's the basics of relays and what they are and how they work. If you have any questions, please feel free to comment. You can send us an email at info@thegeekgroup.org, or you can just go right on the website, www.thegeekgroup.org, and join the forums, become a member, get involved. And by all means, donate, because we want to build Avalon. We are building a very big school, and we want to get your help to do it. So check us out, www.thegeekgroup.org, and come be a part of history. I'm Chris Bowden. Thank you guys for watching. I hope I could help you learn a little bit more about science and technology, and I'll see you next time. I'm going to get back to work. That's it.